Good afternoon. We are MDEM Consulting, and today we will talk about hydrogen supply chain. First, we will describe what is hydrogen, how and where it is used, and after we will describe the main downstream and upstream supply chain challenges. So let's begin with. Hydrogen molecule is composed of two hydrogen atoms. When burned, the hydrogen reacts with oxygen to form water and releases energy. The energy released enables hydrogen to act as a fuel, hence it is usually considered an energy carrier like electricity. Hydrogen is the most efficiently used in fuel cell. The most common are proton exchange membrane fuel cells. The hydrogen enters the cell where electric current and heat are created while forming water as exhaust. These cells are suitable for homes and cars due to lower operational temperature. The supply chain of hydrogen as a fuel is fairly simple. It starts with the production by using different sources and methods, followed by storage and transportation, ending with the fueling stations. In our further analysis, we will focus on electrolysis production supply chain. The above diagram describes the supply chain where the electrolysis method is used. We will further break down this process starting from upstream, covering raw materials and production, to downstream, including compression, storage, transportation, and distribution. The hydrogen is produced by using two main raw materials, electricity and water. It is then compulsory to have a reliable source of both to be able to produce hydrogen sustainably. The electricity can be produced by using renewables like solar, wind, or fossil sources. The water used for electrolysis has to be clean, and that represents a challenge. After the production, the hydrogen is in a gaseous form and has to be compressed and stored. Hydrogen is compressed in the tanks with a pressure ranging between 350 to 700 bars. Car manufacturers such as Honda and Nissan developed a carbon composite tank solution for storing hydrogen in vehicles. Today, hydrogen is transported from the point of production to the point of use via road in cryogenic liquid tanker trucks, gaseous tube trailers, by rail or barge. Hydrogen used in portable or stationary applications can be delivered by truck to a storage facility or in cylinders, similar to the propane used for gas grills, or in cartridges that would resemble a battery. It can be used in fuel cells or internal combustion engines to power vehicles or electric devices. Hence, the most common use in a fuel cell, as we described earlier, designed to power vehicles such as cars and buses. It is also used as a fuel for the propulsion of spacecraft. Supply chain begins with upstreams. Problem here create exponential problems in the downstream segments, as the majority of supply chain cost is determined by the efficiency of the upstream processes. A focus on this area typically yields greater results and have a positive impact on downstream. Upstream optimization requires a holistic approach to ensure that the concerns of the respective challenges are recognized and addressed. The main challenges we can mention for the hydrogen productions upstream on the supply chains are sources, as water and electricity is the primary needs, strategic location of production, with different policies and subsidies attributing to the cost of production, and equipment suppliers, as an abundant amount of small-scale sized and low credibility of manufacturers creates challenges in the supplier selection. We then concentrate on the most important upstream challenge, which are procuring electricity and water sources. Electricity cost accounts for 70% of the total cost of hydrogen production, and bearing in mind the increase of electricity tariffs and ensuring the electricity we use is preferably generated from renewable energy, it becomes a challenge to consider all these factors. Similar to electricity, ensuring fresh water supply for the production is also a challenge. Only 2.5% of global water can be used directly. Bearing in mind that most are locked in glaciers, a small percentage of groundwater can be used without further process. This means the location must have low prices of water in adequate amount and excellent water infrastructure. As for the sourcing challenges, three solutions exist. First, to produce where sources have the lowest cost, which serves as a short-term solution. Second, together with association lobbying the selected country's government for hydrogen technology incentives, which serves as a much longer-term solution. And third, selecting location with existing renewable and green policy that would benefit the production in a more sustainable way. The main challenges we can mention for the hydrogen production downstream on the supply chains are distribution, as transportation requires costly special storage and there is no existing network for hydrogen supply through pipelines. strategic location of production, as there are just a few hydrogen stations, and standardization. Each manufacturer has different connections and requires pressures. Strategic location for the production and fueling point is important. We can consider the following solutions. Production off-site provides space to develop own energy sources through renewables, and mass productions allow for low cost. But we will still have to consider a major investment, expensive transformation costs, and losses to hydrogen fuel stations. Forecasting is complicated as it is a new market. Production on-site hydrogen stations, several brands offering on-site production packages that would save transportation costs and reduce the initial investment. Production is done in smaller volumes and easy to scale and replicate, but they would depend on reliable electricity as there is not enough space for renewable options and clean water supplies. Production on-site multi-fuel stations requires partnerships but allows to reduce transportation costs and delays, uses the existing station infrastructure, water and electric supplies. This adds convenience for users and helps transitions towards hydrogen, reducing installation costs. Brands are evaluating multi-fuel station, but usually they would transport hydrogen to the station, as is often produced in off-site facilities. To conclude, hydrogen industry has still a long way to go, especially for fuel cell purposes compared to electric vehicles. While the solution provides aim to reduce costs, there are still a lot of supply and economic challenges to implement it as a green fuel. Countries are exploring hydrogen benefits that would be one of the solutions in tackling climate change issues. We can expect major positive changes in the hydrogen landscape in the near future with the support of technology development, efficiency increase, and sustainable policies. This is the end of our presentation. Thank you for your attention.